In this short tutorial, we're going to download publicly available data about highly granular population estimates, and we'll visualize the population and the youth ratio in different wards across Kenya. Now, to do this, we'll use a data set from Facebook's Data for Good program called the High Resolution Settlement Layer, also known as Population Density Estimates. Now, if you haven't already done so, please make sure to watch the intro video to this tutorial series to learn more about the Data for Good program and its privacy-preserving datasets. Now, the dataset we'll look at in this tutorial can help answer questions like, how many people are estimated to live in a given area? How do these estimates differ between rural and urban areas, or by age, or even by gender? Facebook's Data for Good team has partnered with Columbia University's Center for International Earth Science Information Network, or CEISN, to create highly detailed population estimates down to the 30 by 30 meter square cell across a global grid. The Data for Good team uses machine learning to detect buildings from satellite imagery while using CEISN data to overlay population statistics across the mosaic of settlements around the world. This means, by the way, that there's no data from Facebook in this dataset. Now, we've already seen this data being used in the real world. The NGO World Vision supports water, sanitation, and health in underserved parts of the world. By using this dataset, they estimated the proximity of the population in a ward in Zambia to a working water source. World Vision found that 77% of the population, or nearly 20,000 people, live beyond the standard distance to a functioning water point. Many of these people would have been hidden or missing by less granular or less accurate population estimates. Now, check out the link in the description below to follow this case study more closely. In the meantime, let's get started. So the first thing we're going to want to do is access the dataset. Now, like several other Data for Good datasets, the High Resolution Settlement Layer dataset is available at the Humanitarian Data Exchange, which is a global website, an open data portal where different organizations share publicly available insights for humanitarian and international development purposes. So what you want to do is visit the Humanitarian Data website at the link you'll see here on the screen, and then just look and search for the Facebook organization. Once you get there, you'll see a really big list of a lot of different data sets that the Data for Good program is sharing. And under the tags on the left-hand side, select the baseline population filter. From that, you'll see dozens and dozens of individual pages for data sets for this particular population density data set for different countries. So I'm going to go ahead and search for Kenya and open up the high resolution population data set for Kenya. Now, once you've done that, you'll see several files available on this page. Now, generally speaking, this data set is made available in two different formats: as a CSV file, which is basically a spreadsheet file where each row is a latitude and a longitude for a particular country, and the other style is a GeoTIFF file. What we're going to do is use a GeoTIFF files, and the main reason for that is they're much smaller than the CSV files. For some perspective here, the CSV file for all population data in Kenya is over 2.5 gigabytes, and that's much larger than the smaller GeoTIFF file. So let's go ahead and download this first file here, which is Ken General 2020 geotiff.zip. Click download there, and that, as the name suggests, refers to the general entire population. And then scrolling down, you'll see another file called Ken Youth 1524 2020. So this is a population estimate data set for the youth between 15 and 24 in Kenya in a GeoTIFF file. Go ahead and download that one as well. Now, we won't open it yet, but once you do open these files, we'll see that it's a bunch of points on a map. And while that can be very useful to understand custom areas, a lot of us in the real world work in administrative areas like country levels, or districts, or regions, or counties, or even wards. These administrative areas can be really important to deciding how and where we deliver services and where gaps are. And so what we'll do in this tutorial is get administrative boundaries for every ward in Kenya and use that to aggregate the individual point data that's available on the Humanitarian Data Exchange from Facebook. That way, we'll be able to do math and calculations about population density estimates within administrative areas that we care about. So to do that, we need to download one more file, which is basically a catalog of the administrative areas in Kenya. Fortunately, there's a resource out there to help us get these administrative boundaries. GADM, or GADM, maintains country and subnational level administrative boundaries for countries around the world. So you can visit gadm.org and then select the country of Kenya, And you can see there you can download administrative boundaries in different file formats. Go ahead and just download the shapefile. You can do that by either clicking on it or on a Windows, you can right-click and click Save Link As. Now once we have the datasets downloaded, we need to do one more step, which is download the geospatial software that we'll use to analyze this data. Now you can try to use some free online tools to visualize these datasets, but these are so large, millions and millions of data points, that you might benefit from downloading this software and running it on your local machine. Now the software that we'll use is called QGIS. It's a widely used, open source, and free-to-use software that works on different operating systems. Just visit qgis.org and choose the appropriate download file that you need. But go ahead and install whatever version makes most sense to you, and once it's installed, you can open up QGIS on your computer. Now we're ready to ingest the data and start looking at it in QGIS. So QGIS is pretty advanced software, but I don't want you to feel too intimidated by it because we'll just focus on some basic essential features to get us to visualize this data set. At its core, you'll see at the top of the QGIS interface a lot of the usual kind of options where you can edit, save your project, and make a few other tweaks. There are a few other toolbars as well, and it's important to note that depending on your version and what operating system you're looking at, your interface might look a little bit different than mine. If I talk about a specific feature or a specific function and you can't find it where it looks on my screen, give it a quick Google with your operating system or your version, and you'll find some screenshots online of where to find this. So what we're going to do is, essentially what you have here when you open QGIS is on the left side, the top left, we are browsing our desktop for different files. The bottom left is our layers window. So when we bring a file into our map here, it'll show up as a layer on our map in that window. You'll see in a second, when we add a layer, the middle section here becomes your canvas and where you can really start looking at the actual data visualized and displaying geospatially on a map. And on the far right is different toolboxes or toolbars depending on what you're looking at. So we're going to get started by loading up the shapefile data for the administrative boundaries of the wards in Kenya. So to do that, just navigate on the left-hand side towards the file on your computer. You don't need to unzip the file. As you'll see here, there's a drop-down next to this zip file called 𝗥𝗲𝗳𝗲𝗃, which is the one we downloaded from the website. And when I do that, you'll see I have different versions of SHP, or shape files, that I can download. We're going to download the one that ends in 3 because we're looking at the ward level, which is the 3rd administrative level according to 𝗥𝗲𝗳𝗲. So we'll click that, right-click it, and say Add Layer to Project. It might take a little bit of time, but you can see already what's happening here. It's zoomed us into Kenya, and it's visualized this data here on this map for us. We can see the administrative boundaries for different wards. Now, I'd like to make a couple of small, quick changes to the stylings here, just to show you how to make those changes and to make it easier to look at for this tutorial. So I'm going to right-click on the layer in the layer window right now and click on Properties. Now here you'll have a wide variety of properties that apply to this particular layer, in this case the 𝗥𝗲𝗳𝗃 layer. And I'm going to jump over to the symbology option, which is basically the way that the layer looks on the map. And I'm going to click on the simple fill, and I'm actually going to change the fill color to be transparent. And I'm going to change the stroke width. I'm going to hit down here. The stroke is just the outline to hairline. And then I'll hit Apply. So now we can see our administrative boundaries for Kenya on the map, and let's go ahead and bring in our population density estimates. Now over in our browser on the top left window here, you can see quite a few files I've saved, and one of them is called pop-all.zip. Now that is the exact same file that we downloaded from the Humanitarian Data Exchange. I just renamed the file to something shorter, in this case pop-all. The other file we downloaded from the Humanitarian Data Exchange was the youth one, and that one's right beneath it called pop-youth.zip. Now again, just as with the shapefile, we do not need to unzip anything here. In this case, under pop-all-zip, I hit the down arrow, and I see Ken General 2020, which is the general population. That should look familiar, and we'll go ahead and add that layer to the project as well. Now, one thing to notice here is we are loading millions and millions of data points right now. So you won't see it change immediately in QGIS, and the load time will vary depending on factors including your computing power. You can know that something is being loaded. At the very bottom here, you have this little blue icon, kind of a thinking bar, to let you know that QGIS is doing the task that you asked for. It's just taking some time. So you might need to wait a little bit for all these population dots to load. So you can see now that the file has been loaded and is now displaying here on the same map above the layer of the shape files for the administrative boundaries. We can see all these little dots. You might have to zoom in and you can see some black areas at the top that represent a really dense section of these dots. But like I mentioned earlier, each item in this data set is a point in space. And it'd be much easier if we could somehow accumulate or aggregate all the population estimates within each ward. So to do that, QGIS lets us do something called zonal statistics. And what we'd essentially like to do is for any given zone, in this case a ward, we would like it to do a certain calculation. In this case, add up all the population estimates that are within that administrative boundary. So that's what we're going to go ahead and do. Now to show you what the end game is here, I'm going to show you what the data currently looks like in the shapefile. So if we go to our layer, 𝗥𝗲𝗳𝗲𝗃, right-click that and click Open Attribute Table, this will give us a peek into what's actually behind these administrative boundaries. And you can see here, it starts to look a little bit like a regular spreadsheet. And you notice some columns of interest here, namely this column here, GID 3, that's referring to the administrative level 3 or ward, and name 3, which is also the name of the ward. So this is just a useful kind of way to check that you're making sure that you're looking at the right data. This is exactly what we wanted, which was the ward data. And ideally what we'd like here is on the far right, we'd like a new column that says something like total population. And it would use our population density estimate layer to, again, aggregate all the population within these wards and then put that number in a new column here. And that's what we'll do with zonal statistics. So to get started with our zonal statistics, we want to make sure again that both layers are in here, both the administrative boundaries and the population density data, which we can see are on the bottom left here. And then we're going to go and open our processing toolbox. So click Processing, click Toolbox, and you'll see it show up on the right-hand screen. The best way I've found to do it here is just to search zonal. And here you'll see that we have a processing tool called Zonal Statistics. Go ahead and double-click that. Now once you double-click that, you'll see a window pop up, and we're just going to enter in a few basic parameters here. The first is the raster layer. And the raster layer in this case is our population density layer. So I'm going to click on that. You can see it's automatically found the only layer that's raster, so you can click on that. You can leave the raster band as it is. And then for our vector layer containing the zones, we know that's our administrative boundaries. And you can see it's already pre-guessed that that's 𝗥𝗲𝗳𝗃. Now it asks you to give a prefix to the column. We'll just call the prefix maybe total pop. And it's saying, what statistic would you like us to calculate for each ward? Right now, 3 options are selected. In this case, all we care about is the sum. So you can click OK, and then you'll go ahead and click Run. Now, just so you know, when you hit Run, because there's so much data in here, again, it will take quite some time to run this process. So I'm going to click Run right now, and here we go. So one of my favorite things to do to check to make sure this worked out is to go back to that attribute table again. So in the Layers window, find the layer that you just merged. I called mine Pop plus 𝗥𝗲𝗳 just to let me know that I've combined 𝗥𝗥𝗳𝗃 with the population zonal statistics. And if I right-click on that, again, this is the layer that we were just working on, and then click Open Attribute Table, it'll open up those familiar columns again with the wards that we had seen before. But just as we had hoped, on the far right, we'll find a total sum, or whatever you happen to call the prefix when you were setting up the zonal statistics, a new column. And in that column, you can see for every ward, we have the population density aggregated or accumulated up to that ward. We just conducted our first zonal statistics, and we're in a really good shape now to do a couple other similar things before we can visualize this. So now that I've shown you what's possible with zonal statistics, let's go ahead and try to visualize a response to a question. In this case, what is the percent of the entire population that's estimated to be youth in each ward around Kenya? Now to do that, right now we have the total number of estimated population for each ward, but we also need to add a new column now of our estimated youth population in each ward. Again, we're going to navigate to our folder, and we're going to add in, this time, not the all population file that we downloaded from Humanitarian Data Exchange, but this time we're going to add the youth one. So right-click on that and click Add Layer to Project. You can see I've already added it here. It's in my Layers tab. Once we've done that, we run the exact same steps. Go to Zonal Statistics. You can search for that in your processing toolbox. Open it right up. And our raster layer this time will be our youth one, not our general one, which we already did. And our vector layer, in this case, will be the pop plus 𝗥𝗲𝗳, because now we want to add a new column to that one, which is youth. So the end result will be a administrative boundary shapefile with a column for all population and a column for youth population. So here I'm going to change my output column prefix to something like youth pop. I'm again going to make sure I select just the sum as my statistics to calculate, hit OK, hit run, and after some time it'll do the exact same calculations as before. Now once it's ready, again, you won't see a difference, so you might want to rename the layer again. This time I called it pop plus youth plus 𝗥𝗲𝗳𝗏. Right-click that, click Open Attribute Table, and this time we'll scroll all the way to the right, and we'll hope to see not only our sum for the whole population in each ward, but also the sum of our youth population in this ward. And sure enough, with the attribute table opened on this updated shapefile, we scroll over and we'll see our total population number there, and then right next to it, after a couple of blank ones, we'll see our youth sum population estimate. So now, take a step back to think what we've done. We took these really large, complicated data sets that were hard to use, and we've aggregated all the individual dots and population dots to specific wards. And we could have done anything else. We could have used administrative boundaries for regions or districts or a country, or even a custom shapefile to get these statistics done. Now, the last thing we want to do is create a new column here which contains the percent of the entire population that's youth. And to do that, within our attribute table at the top we have a toolbar. Now I know these icons can be really small. If you mouse over them, it'll tell you what each one is, and towards the right we have something called a field calculator. So go ahead and open that, and as the name suggests, we're going to run a quick calculation on the fields or the columns of this data set. What I like about QGIS is it makes it pretty intuitive to build a formula. So what we'll do in our field calculator here is we're going to just do a quick division between the youth sum and the total sum. So we can see our column names in the background, and when you start typing in youth sum, you'll see it shows up, and I can just click it there, double click that, and then I'll do divided by, and in this case total sum looks like this in my data set, total sum. And then we'll give it a new field name. We can call this one, let's go percent youth. Our field type here is going to be a decimal because we're making it a percent here. And the length here we'll say is 3. We don't need 10 digits, we just need 3 digits for our percent. And once we've done that, we can hit OK, and then close out, and in a few seconds you should have a new column on the far right of your field here called percent youth. And you can see here we have our percent youth for different wards across the entire country. The next thing we're going to do is export this specific layer as a different file that's easy to visualize in one of my favorite tools called Kepler. So to do that, on this updated layer, right-click, hit Export, and say Save Features As. And you have many different file formats you can use here. For the purposes of the tool that we're going to use a GeoJSON file format, which is a really lightweight, lean file format. Give it a name however you'd like it. We might call ours percent youth Kenya. And then go ahead and hit OK. Make sure you know where you're saving it. Once you hit OK, you can close it, and you now have a file ready to visualize. So let's jump over to Kepler and see how that looks. So to visualize all this data, one of my favorite tools is called Kepler. You can visit it at 𝗥𝗲𝗳𝗏, and once you get there, you can click Get Started. And one of the cool features about Kepler is that all of the data that you analyze or that you visualize all happens locally on your machine in your browser. So if you're working with potentially sensitive data, this is a great resource because all the data stays on your machine. It's also open source, and the interface is pretty easy to use. So I really like this tool. Now to get started, what we'll do is add our data to our map. As soon as you click Get Started, this window shows up, and you can browse for your files. In my case, I'm just going to drag and drop my file here from my folder. I actually named my file pop plus youth plus 𝗥𝗲𝗳𝗏.geojson. Again, that GeoJSON file format is what we exported from QGIS. I'm just going to drag that over. You can see it's about 69 megabytes, which is actually pretty small. Keep in mind the data set that was a CSV that we could have downloaded from the Humanitarian Data Exchange was over 2 gigabytes. So this is definitely a leaner version that we've got here. Now, that said, because of its size, it'll take a bit of time to load in your browser, and you can see it loading here. We'll just give it a second. Now, as soon as that data is added to your map, you'll see it show up visually. It might again take some time. Now, as soon as we get that data uploaded, it automatically visualizes it on this lean, sleek-looking map here. So I'm really happy with this, but there's quite a few changes we want to make. Specifically, we'd like to look at the ward level, and we'd like to shade the color of each ward according to the percent of people in that ward who are estimated to be youth based on the Facebook population density estimate data that we used earlier. So a quick introduction to the interface. You can see the map in the canvas area is front and center. On the left-hand side is your control panel, and hidden at the top right here are a few additional kind of features or options you can choose, like toggling a legend, which we will do later. But what I'd like us to do is basically look over on the left-hand side under our layers. You can see our population youth GADM layer here, and you can see that it already added that onto our canvas here. If you click the down arrow on this layer, you can see all of its settings, and here's where we'll change quite a few different features. The first thing is our fill color. So if we click on the fill color dropdown, what we'd like to do is color each geography, in this case each polygon or each ward, according to the percent who are youth. And you can see hopefully a familiar label here. This is from QGIS, the column called %youth that we created. And well, you can also change the color. Now it comes with a bunch of beautiful pre-selected color schemes. I like white to blue, so I'll choose that one. When we choose the white and blue color scheme, you can see what it's done here, which is it's shaded every single ward according to the percent that it's youth. And you can immediately start seeing some very interesting insights about where there are higher or lower, relatively speaking, percentage of youth across Kenya. One more thing I'll do is I'll just change our stroke color. That's the outline of each ward to make it look a bit nicer. And then over at the top here, we can choose a few other options. At the far right, we can choose our base map option. I'll click on that. I'll just change our base map to a different one. Already, I love these options because they're so beautiful and easy to use. It makes it for a very visually compelling product that you can share with people. I'll make one other change here, which is under the arrows here, we have an interactions option. A tooltip is what happens whenever you mouse over a specific area and a little pop-up shows up. So we're just going to customize our tooltip here, and we'll say that we'd like it to show the name 3, which is the ward level 3, so the name of the ward, and also the percent youth. You can see right away then if I mouse over this ward, I'll see it's called Mycona ward, and it's estimated that 20% of people in that particular ward are youth. So the last thing we can do now is we can export or share the result here. At the top right, we have a share feature that I really like. Before I do that, actually, I might enable my legend so we can see the percent for each one. And once I click share, I'll just export an image. And you can export this in many different ways as well. I like an image because it's a beautiful high-resolution image that you can share in presentations, for instance. Now, however you decide to export the image, or as you're doing this, it'll take the canvas view that you currently have. So make sure you configure your view when you zoom in to where you want to be so you can export the image. We'll wait for that to load. We'll add the legend onto the map. We'll keep our resolution at 1x. If you do 2x, that's really useful if you want to make any prints. And then once that's ready, you can click download. Within a few seconds, you'll have a beautiful image that looks something like this. And there you have it. Take a look at this visual that we just put together in the past few minutes. To recap, we took large GeoTIFF files containing points of population estimates from throughout Kenya and containing millions of these points. We layered that against the shape files of the administrative boundaries of wards, and we ran some calculations in QGIS to demonstrate the percent of all people in each ward who are estimated to be youth. If you were an NGO looking to engage youth in a particular area, you might use this data to find out where you might want to be working and with whom. Now, this population density data set is one of the largest data sets that Facebook Data for Good makes available, and it really shows in the data formats and sizes that it shared it. I mean, if you're like me, until recently, I didn't know what a GeoTIFF file is, and I certainly wasn't sure how to open such large CSV files in Excel. But with the help of some free offline and online software, together here we were able to transform this truly massive data set into a manageable and interactive experience that enables exploration and decision making. And we should be really proud of that. Well, there we have it. If you're looking for more tutorials like this, check out the playlist link in the video description below. We've also shared some links down there to similar tutorials like this one about this dataset developed by others to help you explore the insights. In the video description, you'll also find important resources, including links to the case study I mentioned earlier, as well as the methodology behind this Data for Good dataset. And before you go, please help us to improve these tutorials. Take the short survey that you see on the screen right now to let us know your thoughts and let us know how you might use these insights. Until next time, see you soon.